Hello, welcome to the third part of our fifth lesson in our fourth unit, Graphing Quadratics, in our grade 10 academic math class. So this is probably going to be like the first four-part lesson that we've done. Honestly, this is just a really important concept and I want to make sure that you understand it. So I'm taking my time. Hopefully you guys are feeling pretty good about it by now. Just in time for us to throw in, to ratchet up the level of difficulty a little bit. So let's start. We have y equals negative 1/2 x squared plus 5x minus 4. So two things to notice. The first is, this is the first time we've actually had a negative a value that we're going to be factoring out, so that's important. The other thing is that this is a fraction. That's also our first time factoring something like that out of an equation. So let's get started with the first step, which is, of course, to common factor out the a value. So we're going to be factoring out negative 1/2, and we will be left with x squared. That one's pretty obvious. The plus 5x is going to be more problematic. Now, if we factored a negative value out, it stands to reason that we would have a negative value here as well. The hard part is figuring out what the number is that should be here. And I'll remind you that whatever this value is, when we multiply it by negative 1/2, we have to end up back with 5. I think that explanation typically helps students see that this value, interestingly enough, is going to be larger than 5, which is sort of, again, counterintuitive. But if you were to multiply something by negative 1/2 to get 5, that value would have to be negative 10. And I'll just sort of show you that down here. So negative 10 times negative 1/2. 2 divides into itself once. There we go, and two negatives will result in that positive 5, which is what we started with. So that's the thinking behind it. Is it weird and, like I said, counterintuitive? But that's how it works. So that's going to be for us a negative 10x that we have there. And then close it up, and there our negative 4 shows up again. So hopefully that makes sense. If you want to watch that portion of the video again, please do, since it's important for sure. So let's move along. Negative 1/2 x squared minus 10x. Now we're going to be building our perfect square trinomial. And I'm going to change up our formatting here just a little bit, since I want us to move a little bit away from writing negative 10 over 2 all squared. I want us to think that we are adding a value and then subtracting that exact same value in order to create both a perfect square trinomial and then to balance the equation. So what's that number going to be? Because I know that we can do this in our heads. So our b value is going to be negative 10. We're going to divide that by 2, so that's negative 5. And then we square it. So the value that we're going to see here is going to be plus 25 and minus 25. Now, if that's too big a leap, it's no problem. I would just recommend, if you need to make that calculation, you can just sort of scooch out here. You can put negative 10 over 2 squared is going to give you negative 5 squared is going to give you 25. Totally fine with you sort of doing a little shout out for that, but I'd like us to move to a slightly more streamlined version of doing this, and this is what I would recommend. Okay, so we're now at the point where we've built our perfect square trinomial. We can't go on to factor this yet because we still have this pesky negative 25 hanging around. So how do we go about getting it out of the brackets? Well, we introduced it into the bracket as a way of balancing the equation in a bracket that had already had negative 2 factored out of it. So for us to break this out of the bracket, we are going to multiply it by negative 1/2. And let's see what happens. So as we do that, that's going to give us, well, we know it's going to give us a positive value. And without introducing decimals, that's going to give us just 25 over 2, which I'm happy with. We can just leave it as a fraction. Okay, so let's do a rewrite here on our next line. And the next line, oops, wrong color. So we're going to go with negative 1/2 bracket x squared minus 10x plus 25. And now we've got these other two values out here. We've got plus 25 halves. And now we've got negative 4 halves. But let's also do a little bit of math here so we can get that common denominator happening. Because instead of just being negative 4 over 1, what value would that subsequently be over 2? That would be negative 8. So we have negative 8 halves as well. So now we're at the last step. We're going to be doing some factoring here. So this is negative 1/2. And remember, we're looking for the thing that multiplies to plus 25 and adds to negative 10. So that's going to be negative 5 all squared. And again, I want to point out this negative b value here tells you that this is going to be a negative b value in the brackets. Just fancy. And now we have 25 minus 8. That's going to give us 17. Oh, that's the highlighter. Plus 17 halves is what we've got left there. And now we've been fully factored. We've been through the procedure of completing the square. So, does it say list the vertex this time? Oh, I just, look at that, saved a ton of space that time. So our vertex is going to be 5 and 17 halves. That's totally okay. It's not easily graphable, but that's not necessarily the goal right now. Okay, so hopefully this example worked for you. Let's go on to the fourth and final non-graphing example. So again, I'm going to continue to sort of just talk through it. First thing we want to do is common factor out negative 3. That's the a value. And we'll be left with x squared. Now again, notice that this is a negative value we're factoring out, so we're going to have a plus 3x remaining there, minus 25. So now we are going to go about completing our perfect square. Now minus 3, x squared plus 3x, we're going to add something, we're going to subtract something, and then you've got the minus 25. So what's tricky about this one is that our b value is positive 3, and it just isn't very nice in that we need to cut it in half, so that's going to be 3 over 2 all squared. Well, 3 over 2 doesn't come out to a nice number. It's 3 over 2, or 1 and 1/2. So we're going to leave it just like this, and now we're going to square it. So a squared numerator and a squared denominator results in 9/4 for us, which is kind of a gross fraction, but it is what it is. So we have add 9/4 and subtract 9/4. Not pretty, but it is what it is. So here we are at the next step. We are just about ready to factor. However, we need to get this negative 9/4 out of the bracket so that we can factor it. And how do we do that? Well, we already put it into a bracket that had negative 3 factored out of it. So we are going to multiply it by negative 3. That's going to work for us. And in doing so, we end up with a positive value, which is good. So we have plus, and 3 times 9 is 27, and 4 times 1 is going to be 4. So we are going to add 27/4 to this. Beautiful numbers. Doesn't change the fact that we're on the right path. So our next line will be negative 3, x squared plus 3x plus 9/4. And we have plus 27/4. And again, like I did last time, I'm going to figure out what negative 25 would be if it were over 4. So we have negative 25 over 1. What would that be if it was over 4? That would be negative 100. So we have minus 100/4. Oh, it's looking amazing. Okay, so now we are doing a couple things. The first thing we're going to do is we are going to factor here. Now, what's interesting about this is that you might not know how to factor this, since we haven't really dealt with quadratics where we ask ourselves what multiplies to plus 9/4 and adds to 3. That's sort of a weird thing for us, but I will say the clue to what goes into this bracket, and we know of course that it starts with an x and we'll have a plus in it since this has a plus here. The way to figure out this value is to ask yourself, what were the values that we had once we cut the b value in half? So half of this, and we did this calculation up over here, this is actually the factored value. It's half of b is what normally goes into these brackets, or what goes into these brackets. So if you're struggling to factor this, just recall that what we had done before we ended up expanding this out. So again, you don't have to copy this down, but the idea was that if we had x plus 3/2 and times x plus 3/2, what we would have done when we expanded it out, eventually we would have arrived at 9/4. And the two middle values would have been plus 3/2 x and plus 3 halves x, which gives you 6 halves x, which is 3x. So that's where it comes from. The shortcut, as I said, is just to recognize that half of b is what's going to go in that bracket. And now we need to just do a little bit of simplifying here. We have the beautiful 27 fourths minus 100 fourths, and that's going to give us negative 73 fourths. Whew! Vertex looks positive, is negative 3 halves and negative 73 fourths. So sometimes it just doesn't turn out pretty, but it is absolutely correct. Our direction of opening is down. We can figure out our plot pattern. So from here, I want you to just reflect on what we've done. We're going to do one more where we're going to get to not only complete the square, but then graph it. So it's going to be great. See you in part 4.